Okay. So, hopefully we're moderately okay with factoring what are called monic trinomials. Out of all the stuff we did last time, what's the difference between this and those? Oh yeah, no. Say again? Function of x. Oh, was I writing y last time? Or was I not even writing y?
You're writing y.
I wasn't even writing y. Okay, so, fair enough. Firstly, yes, there's an f of x out the front. That just means y equals, that just means we're going to deal with the graph in the end. That's not what I'm actually interested in. What's different between this and the things we were dealing with yesterday, or Monday?
There's no multiples in x squared.
Right, now I've got something multiplying this x squared. Cool? Okay, great. Intuitively, how would you like to deal with that?
1, 5,
Right, if we can just get rid of this as a common factor, that saves us a bit of time. Okay, cool. 3 x squared minus 8x minus 20. Everyone's happy about that?
Yeah.
Cool. What would you like to do from there?
Recognition.
Say again?
Recognition.
Recognition. Cool. Okay. What can you recognise?
Minus 10 plus 2. Minus 10 plus 2.
Cool. We're all happy? Yep. Go. Beautiful. Right. Almost always, whenever you've got, so this is called a non-monic. It's monic if it's 1. If it's anything other than 1, it's called non-monic. As soon as it's non-monic, the first thing you want to try to do is factor out something. If it factors out completely, brilliant, you're into an easier problem. So you always want to try to make things easier for yourself whenever you can. Cool. Fine. And then we factorise down as far as it'll go. Great. Okay. What about this boy?
Could you not still divide by 8 anyway?
You could force it to divide by 8. Is that going to make life happy?
Not really.
Okay, so we'll do it just for the sake of it now. 22 divided by 8 is what? 11 on 4. Add 15 on 8. Are you happy with how that looks?
Not really.
No. Okay. Let's say that I gave you that thing in brackets originally. What would you do from there? If there was no 8. So if I just gave you that, and I said, okay, factorise this.
14 squared.
Right, you'd have to complete the square on this, which is going to suck. Yeah? Cool. So we probably don't want to do that if we can avoid it. Okay. So, if you can't completely factor it out, it is usually worth trying at least to do Berry method. So, what the hell is Berry method? First, last. Multiply together. 8 times 15.
A lot.
A lot.
120.
I think we get 100 and
120, yeah?
Yeah.
Go. 8 by 5, 40. 8 by 10, 80. 80 and 40, 120. Cool. So we're going to take, where am I going to put this? Put it here. Cool. I want to break that now.
10 and 12.
Alright. I need two numbers that multiply to 120 and add to the middle. Cool. Alright, turns out that that's 10 and 20. Okay, great.
10 and 12.
10 and 12, sorry. We will put 10 and 12. Doesn't matter which way we're in. You can come either way.
check gives you.
Next part. Oh, there he is.
Hey, take it. Welcome to Ring Bear Method.
Just on 5 minutes. Get down, Jake. Where are you? Go. Cool. Alright. Now comes the chunky bit. Cool. Alright. These two will multiply to 10, these two will multiply to 12. Yeah, you already know it. Okay, hang on. The two squares are going to multiply to the front. The two circles are going to multiply to the end. That's a terrible circle. Let's try that again. Cool, cool. Okay. you can flick through a couple different versions of this. Eventually, hopefully you're going to find
5, 2, 3, 4.
5, 2, 3, 4. So, cool. 5 and 3. Wait, we're backwards. Hang on. 2, 5, 4, 3. 2, 5, 4, 3. Cool, okay. So, 2 and 4, 8, 5 and 3, 15, 2, 5, 10, 4, 3, 12. Cool, everything lines up. Okay, great. Now, if you're struggling to find those, the best way you can do is literally, almost by total exhaustion, you just go, okay, what does 10 divide by? 1, 2, 5, 10. So this would have to be, 10, 5, 2, 1. What does this divide by? 1, 2, 3, 4, 6, 12. 12, 6, 4, 3, 2, 1. And then you just start going through, okay. 1, I need to get to an 8. I don't have 1 and 8, so 1 can't work. 2 and 4, that could work. 5 doesn't go into 8. 10 doesn't go into 8, this has to be 2. You can very quickly eliminate them down. Cool. Might leave that there as a relic. Okay. Beautiful. Great. So, what does that mean? That means open bracket. Square, other square. Now the irritating part, this 5 is going to go with the 4 because we need the 2 and the 5 to multiply the 10, so they need to be in different brackets to multiply each other. The 3 comes back over here. You can always check this by just expanding it again. Make sure you end up back where you started. Cool. Yep. Okay. Brilliant. Before I do that one, I'm going to do this one. Yep, move this across.
It's not pointless. Especially if it's kind of easy recognition.
Yes. Yep, that should work. Okay. Have a crack at that. Brother's already got it. No, just staring into the board. Okay. You get it? Okay. Everyone's like got this by this is 210, yeah?
Mm-hmm. Oh, got it.
Are we struggling with those two?
Yes.
Yeah?
No,
Some got it, some don't.
okay.
I'll give you a little bit more time. Because once you break that, the rest of it tends to fall. That's usually the trickiest bit. If you're struggling with it, taking a look at 210, what part of that number jumps out at you?
21.
21? What does 21 divide by?
10.
Okay. Oh, actually, no, that's not going to help you in the case. Oops, never mind. I'm leaving you down. What is this? Okay. if you get totally stuck, just start listing off factors. So you can go, okay, 1, clearly it's not going to be 1 and 2, 10. 2 in this, it's going to be over 100, still too big. Can we divide this by 3? Yep, cool. You could divide it by 3, but it's going to be more than 3 times.
I'm done.
Yeah, cool. So you keep working your way up. If we keep going, we've got 5 and something, 10 and something, oh, and 7 and something. So 10 and something, okay. 7 would go with 30, 7 and 30, now we're too small. Right, same with 10 and 21, we're way too small now. Yeah, that adds to 31, this is 37. So we go with 5, it's hopefully going to be 42. Yeah, so must divide by 6 as well, because we've got to go beat 5 and 42, that adds up to too much, 7 and 30, not enough. So it must be somewhere in between. Right, and the only number left in between is 6. So we get 6 and, what do we get? Divide by 3 is 7, wait, 6 and 35, yeah. There we go, cool.
Oh,
Yes, cool. So are you okay? Not okay? Yep, you're cool. Okay, we'll do it this way, unfortunately. You're all good? Beautiful, okay. Cool, well, that's fine.
what's the date today?
4. Cool. 7, 1, 2, 3, 4, 5, 6, 7. Right, Tyler.
I got bracket 3x plus 5.
Bracket, oops, you bracket 3x plus 5.
7x plus 2.
7x plus 2. That sounds pretty good. Okay. 3, 7, 2, 5. Looks good. Is that what everyone else has got?
Yeah.
Okay, with the other? Beautiful. Cool. That's about as annoying as those will get. Okay, because 6 and 35, I don't expect it to be overly for you to know your 35 times tables. And 6 is just one of those ones where it's just a little bit more fiddly. That's about as annoying as they'll get. Cool. Right. I want you to factorize. I want you to factorize each of these. Okay, they're not trinomials anymore, so this should be old stuff now. Cool. We're all okay to have a go at that? Yep. Underlay.
Oh, no.
Well, the first one, yeah? Yep. Got the second one? Yep. Just people who get stuck on the third? Okay. Anyone done with offset? Yep, one. This one? Is anyone still trying to do recognition on the third one? Recognition won't work on the last one. I'll give you that break. What's this done now? Nice. Okay, done. Yeah, TJ's done.
You.
Nice. Michaela, you're done? Pretty much. Just gotta still got the hands in. Alright, I'll save you from the pain. Alright, we'll do the first two first. Volunteer. Oops. Wait, this is gonna be blue. 10 is 10. 13, 12, 11, 10. Yep. What do you get?
X plus 3.
Yep. Cool. You both, so just write it like that. Beautiful. Easy. Done. Everyone's happy?
Yep.
Go. Tree. 1, 2, 3. Okay.
X plus minus negative square root of x.
Say again. X
X plus 4
plus 4. Yeah.
minus or negative.
Square. Minus. Yep. How much?
Negative. Wait.
8. Minus 8. Like that.
Yeah. Yeah, that's how I did it, yeah.
Yeah. Cool. Are you okay with that?
Yeah.
No? Okay.
I thought you just square root of 8. So,
So we've got half this is good. Alright. 4 squared gives you how much?
12.
Count again. 4 squared. 4 by 4.
16.
16. Alright. We get 16. We only want 4. So minus 12. There you go. Well, there you go. If 4 squared is 12, you would have been correct, but otherwise, not quite. Cool. Alright. Beautiful. Alright. Is that? Oh. Because you had. No, you had minus before. Cool. Okay, what did you do after that?
X plus 4 minus a negative 12. That's square root of 12.
Yeah, okay. 12.
Yeah, I said to myself that 4 squared was 12.
Shit to myself.
Cool. Okay. You played yourself. Oh well, that happens. Cool. Alright. Anyone want to volunteer for this guy? No? We'll see how far we got. 9. Who's 9? 9. You're up, Jade. Any thoughts? You got nothing? Did anyone attempt to complete the square? Yep, go mate.
Was it open bracket x squared take away 5 close bracket squared plus 75?
So no squared here, alright, because the square's up there. So this to this, and then plus 75, that's what you're saying? Perfect. That's it, that's as far as it goes, right? Because I don't have a minus here to use difference 2 squares, it's done. Cool. Alright.
Good one.
Yeah. Cool. If you run through recognition and at some point it's taking you forever, change gears. Right. That one can't be done by recognition. Q.
That's big.
Okay. Everyone's happy with how we've factorized everything now? Yes. Cool. Yep. Okay. Now what I want to do is sketch these things. Alright. There is. Okay. All of these are going to be what sort of graph? Parabola, right? Parabola. Cool. They're all going to be parabolas, right? Anything that's just got x squares, x's, and constants in there, it's just going to be a parabola, right? So this the algebraic version is called a quadratic. The shape of the graph is called a parabola. Cool. All right. Well, I know that I'm going to end up with some sort of curve. Great. Which way we go? Yeah, no, we'll go here. Cool. Oh, that's terrible. There we go. Switch that on. Okay. Cool. Okay. What do I need to know in order to sketch this thing? Go.
Your x and y intercepts.
Right, x and y intercepts. Cool. Okay. How am I going to get them? Say again.
You already have the x-intercepts.
I already have the x-intercepts. What are they?
Isn't it positive 5, negative 2?
Positive 5, positive 5.
Not positive 5, positive 10, sorry.
Yeah, right, okay. Cool. 10 and negative 2. Cool. Alright, how do you know that that's true? Because you've done it last year and you just know that it's true. Okay. So, what you're doing is saying, okay, I'm going to make this thing equal to 0. Right? What's f of x effectively the same as? Y. If y is 0, where must I be? On the x-axis somewhere. Right? So whenever this is true on this line, I must be on the x-intercepts. So what you're doing intuitively is setting this to 0, going, okay, a bunch of numbers multiplied together equals 0. Well, one of them has to be 0. So if this is 0, well then 10 minus 10 is 0, or if this is 0, negative 2 plus 2 is 0. So there's our two x-intercepts, great. And out here, cool. Okay, and this blue, yes. Cool, okay. Cool, what else do I want?
Turning point.
Turning point, okay. Target,
You need wires.
need a Y. So that's there, okay. So what am I doing?
You have to sub them into your equation.
Sub what into what?
X into the x-intercept.
If I'm here, what do I know?
Oh, you have to sub thingy into 0.
You're floating around it, TJ. Sub zeros into the x's.
Yeah,
There you go.
that's right.
Okay, so I could sub zeros into that, right? And that would work perfectly fine. Okay, so we get 3, 0 minus 10, 0 plus 2. Cool, so I've got 3 times neg 10 times 2 equals neg 60. We're all happy about that?
Oh, why didn't you just put it in the first equation?
Sitting there for free.
Oh, that's right.
Yeah, cool. Okay, great. Now, I haven't labelled these yet because I want to make a very annoying point that you guys are going to have to do, and I will deliberately mark you down every time you don't do it so that you get into good habits. If you just start doing that, I'm going to start making you lose marks. Alright? Has to be like that. Cool, you have to label the coordinate as a complete set. I don't particularly personally care, and more often than not, I will probably just write them minus 60 because it gets the point across. However, in your actual exams at the end of next year, at the end of the year after next year, if you're missing those, you're running the risk of dropping marks. So I want you guys to just be so ingrained to put this that you cannot possibly lose those marks. And I know that's mildly annoying and mildly inefficient, but you'll get over it. Same with these guys. Oops. Beautiful. Okay. this. Cool, okay. Am I all done?
No.
No? What's missing?
Turning
Turning
point.
point.
Turning.
How do I get turning point?
Whatever's in the middle of 10 and negative 2.
Say again.
Whatever's in the middle of 10 and negative.
Right. I know this thing should be symmetric. Cool. To the point where,
Axis of symmetry.
right, that thing, that dotted line there is called the axis of symmetry. It's symmetric around that. You don't actually draw in those dots, that's just so I can label what I'm talking about. Okay, so if this is symmetric, then it must be the same distance that way as that way. So, what's halfway in between 10 and negative 2? Okay, we've got multiple different answers there, so maybe we'll take a second. How do you calculate midpoint?
Negative 2 minus x.
Right, add them together
And then
and divide by 2. Cool, gives me whatever that is, 8 on 2 equals 4. Cool, so we got 4. How do I get this other point? Right, sub it in, so we've got 3, 4 minus 10, 4 plus 2, cool, 3, negative 6, 6. 36 by 3 is what, 81? No. 108. Negative. See, is that right?
Yeah.
36 by,
That's right.
yeah. Let's go. Beautiful. Go. Done. Excellent. I'm going to run one other slight tweak to this. So that's, everyone's happy with where everything came from. Yep, cool, okay. One other slight tweak to this. I'm going to take this rule again. Oops, not that one, the one above it. Cool, let's say for a moment that we forgot how to do our 10 and 2 times tables, which hopefully is really unlikely. We can do the following. I can run completing the square on this. Give me 16, 19 minus 6. I can expand this out. Oh, that's a 3. Like that. Cool. What do we notice?
1, 2, 8. K and K, whatever that thing is, equals the TP.
Right. So if we run completing the square, we get the turning point for free. Right? If you run recognition, you get the x-intercepts for free. This is why it's good to be able to switch gears. Depending on what you want to do, you can immediately go for the thing that will actually get you closer faster. Right? Or you can do it the way that we just did it before, where you go, oh, okay, I've got my 2 x-intercepts, I can find what's in between that, and then figure out this. Fine. Right? We're in methods now, there's multiple ways of skinning the cat. Right? Yep.
If you're doing complete the square,
Yep.
to work out the x-intercepts, just equal 0 and
I'm so glad you asked, AJ.
plus 1
Cool. Alright, to find x-intercepts, what are you doing? Right, you're making this thing equal 0, y equals 0. Cool, okay. Well, I've got 3x minus 4 squared, move the 108 across, divide by the 3, gives me 36, square root that, plus or minus 6, move that across, x equals 4, plus or minus 6, so x equals negative 2, or 10. Same thing. Cool. So you are free to go whichever way you want. As long as you've done it correctly, you should end up in the same endpoint. This is why you want to be good at as many things as possible, because then you can look at it and go, if I do it this way, that's going to suck. What if I do it this way? That'll be easier. I'll do it the easier way. Right? It just gives you options. Whereas if you're a one-trick pony, then you have to just keep bashing your head against the wall, regardless of how difficult it is. Cool. Next guy. Alright. For this thing, we could, in theory, have done that and then completed the square. Right? If you're only a one-trick pony and that's all you know how to do, that's going to make your life really difficult. Instead, we went, oh, we can use berry method, and we've successfully done that. Great, I now want to draw this thing. Not the straightest ever, but that'll do.